Hey guys, welcome back to another software engineer interview question. Today's question is called number of islands, and this is a very popular question. So the question is, given a 2D grid of ones which represent land and zeros that represent water, count the number of islands. And an island is surrounded by water, and it's formed by connecting adjacent lands either horizontally or vertically. And you can assume that all the edges of the grid is surrounded by water, or basically zeros. So this is a lot easier to understand with an example. So if you look here, here's our 2D grid. And you can see that we have 4 ones right there, then we have 1 1, and then 2 ones down here. So the answer here is 3. There are 3 islands, and we know that because first, remember, everything surrounding this grid is water or a zero. So these 4 ones on the top left-hand corner, they're surrounded by water on the top and left sides. On the right side, there's water, and on the bottom, there's water. Now you may be saying, oh wait, there's a 1 right here. Well, that's not horizontally or vertically connected. Because if you take this closest one right here, to the right is a 0 and down is a 0. That's horizontal and vertical. Diagonal would be a 1, but that's not considered in the algorithm. So technically speaking, the 4 ones on the top left is an island. Then we have this one right here. That also is an island because if you look top, left, right, and bottom, it's all zeros. So that's an island. And then finally, these 2 ones, the top, left, right, and bottom, once again, are all zeros. So in this configuration, there are 3 islands. But obviously, in other configurations, there'll be a different amount of islands, and the algorithm should work for all of them. So go ahead. Actually, let me show you really quickly. This is what I set up for the base signature. You can obviously do whatever you want, but I just created a character array that mimics that example. So this is the exact example character array. And then I created a method called number of islands that takes in the 2D character array and returns the amount of islands. And then I just print that to the console. So you can go ahead and pause the video now to try this on your own, and then when we come back, we'll go through it together. Alright guys, welcome back, and hopefully you had an opportunity to go through this exercise, and hopefully you were successful. But now let's go through it together. So just to get us started, I want to make it a little bit easier to read this diagram, so I'm going to mark the zeros in a gray. And this helps us really see that there really is 3 islands. We see the 3 separate groups. Now, the difficult part about this algorithm is once we determine that there is an island by finding at least 1 1, then we have to find out how big the island is. And that can be difficult. And I'll talk about how we'll do that in just a second. But to get us started, we know that we need to essentially check every single element in this 2D array to find out all the islands. So to do that, since this is a 2D array, we'll use a nested loop. So in this case, I will keep track of our outer loops. So in this case, our rows, and J will be each element in that row. And I also start off by defining a variable to keep track of the amount of islands that we have found so far. Okay, so I'm going to add a circle. This circle represents what element the loop is currently at. So since the loop will start at 0, 0, we're at our first element in the 2D array. Now remember, I told you the challenging part of this algorithm is once we find a 1, that's the easy part. The hard part is, well, how do we find out how big this island is? How many ones are connected to this one with the condition of the left, top, right, and bottom elements are 0? Because remember, an island is defined by all the surrounding nodes being 0, and the outside of the array is also 0. So that means everything to the left over here, the top, bottom, the top, right, and bottom, they're all 0. So this is all surrounded by water. So how do we do that? And the way that we're going to solve it, there's two dominant ways of doing this. The way that we're going to use is we're going to use a depth first search. Now, if you're not familiar with a depth first search, the basic idea is to find your answer, you're going to travel as far as you can in depth. So you keep on traveling and traveling and traveling until you found the end of your answer. So then we need to ask ourselves, well, what defines the end of our answer? If we found a 1, then we know there is an island, right? Well, what defines the end of that? What's the end of the island? Well, the end will be once we reach a point where all surrounding sides of that element is water, then we know it's the end. But you may be wondering, well, that's not true, because if I get to the end, it's still connected to other ones, which means that condition of all 4 sides are water can't be true. And the way that we'll solve that is we need to somehow keep track of elements that we already have visited. And there's lots of ways we can do that. We can make an external data structure that keeps track, or since the question does not say we can't modify the array, once we visit an element, we mark it as 0. We make it water. And now we know that we already visited, and it will also help us keep track of our base condition. If everything is surrounded by water, then that's the end. So if we follow that algorithm, let's just very slowly start off. So the algorithm starts by saying, if you see a 1, then increase number of islands by 1, because think about it. If we see a 1 anywhere in this chart, then we know there must be at least 1 island, because there's 2 conditions. Either there could just be 1 1 in all zeros, and that still means there's 1 island, or they can all be zeros, or they could all be 1s, which means there's just 1 giant island, which still means there's 1 island. So I see a 1, I increase number of islands to 1. Then I mark it as a 0. Remember, this is so that we can keep track that we never go back, or that we never include this again in our search. We're marking it as visited. Now, depth first search works by going as far as you can go until you reach your base case, which is going to be all surrounding sides are 0. And then you go back to the beginning. And the easiest way to implement a depth first search algorithm is by using recursion. So recursion is the idea of using a method that calls itself. And you should have some experience with this. I'll eventually make a separate video talking about recursion alone. But you should have some experience with recursion to solve it using the algorithm that I'm going through. Okay, so let's try to walk through what a depth first search algorithm would look like in this case. So if we follow the rule that left, top, right, bottom, that means we'll always search starting from the left, top, right, bottom. And remember, our goal is to find the end. We're trying to get to the end. So if we're at 0, the first search would be left. Since it's a 0, we skip it. The top is a 0, we skip it. The right is a 1. So we hit a point where we have found an element that is a part of our island. Since it's a 1, we know it has to be a part of this island. So we go to it and we mark it a 0 so that we never go back. It has now been visited. And when we get to this node, we start the whole process over again. So we check left, top, right, and since these are all zeros, we don't do anything, and bottom. Once we get the bottom, we see there's a 1, so we mark it as a 0, so we never visit it again. And then we do left, and in this case, it's first check, which is left. There is a 1, which means this is part of the island. So we go mark it at 0, left, top, right, all zeros, and finally the bottom is also a 0. Since the bottom is a 0, this means all 4 sides are 0. And remember, with a depth first search, we're trying to go as far deep as possible. And now the condition is met. All 4 surrounding sides are 0, which means I now know this is the end, and I no longer am diving in this case. So I found the end. So now we're done with this, and now the call stack is going to get popped since we're using recursion, and we're going to go back to whoever called this element. Since we know the previous node called this element, we return back to this 0 right here, and we pick up where it left off. Since it only has done its left search, we now need to do its top search. So we say top, which is a 0, so we do nothing, then right, then bottom. And since now this is surrounded by all 4 zeros, we know this is done, so we mark it as gray. And then we return to whoever called to this element, which is this guy right here. So we go back to that guy. However, it also has completed all 4 search paths. As you can see, it also has 4 gray arrows, left, top, right, bottom, which means it is also done with the search. So we mark it as gray. And then we return to who called it, which was the first element, which it still has one last search. It needs to check its bottom. So it does its last bottom check, which is a 0. So it now goes, we're done here, and it marks it as a gray. And now we know that we're done here, so we can remove all the arrows, and we continue on. So the outer loop will now go, okay, let's find the next one. It keeps on checking all of these. Nope, they're all zeros. This is all water. And we'll continue to do this until we hit our next one. And there we go. So the algorithm states, once you find a 1, increase number of islands by 1. So now we have 2 islands at least. And then we mark it as 0 so that we know that we visited this node. And then we start the depth first search. So we go left, top, right, and bottom. And we didn't navigate anywhere because they were all 0. And since they're 0, we just skip them. But once we do all 4 checks, we know we're done. And now we know this is the biggest the island is going to be. So we mark it as gray and that we're done, and we move forward. So we keep on scanning our array until we find the last island. So we found a 1. We increase number of islands by 1. So now we're at number of islands equal 3. And then we start the search. Actually, first we mark it as 0, saying we visited it. And then we start searching to see how big this island is. So we check the left side. Nope, it's a 0. Water. Water. Oh wait, there's more land. Let's go to the land. Let's mark it as 0. Then left, top, water. This is all water. Water, water. Once we did that, we now have all 4 sides surrounded by water. So we mark it as done. We finish this, and then we return to the element that called this, or essentially in recursion, the method that called this, which is the previous node, the remaining node. And it has one last search, right? It did left, top, right already. So the last one is bottom. The bottom, though, is water. So we're done with that, which means now we did all 4 searches, which means we're now done with this one. And then the final thing is the loop will continue to the end. So we check the last element, and then after that, we reach the end of the array. So we have our answer. The amount of islands in this data set was 3. Now, as you can see at the end, our array is all zeros. And if the interviewer said you can't modify the array, that's fine. Just keep track of the elements that you visited in some type of data structure. And then your condition in your depth first search would include if it was a 0 or if it was already visited by checking your data structure. And that would work just fine as well. All right, so let's go implement this depth first search using a recursive algorithm. So here we are back in the C# application, and we're now going to implement the algorithm that we just went through. So let's scroll down to the number of islands method, and remember, we first started off in the algorithm by creating a variable called num islands. And the idea of this variable is to keep track of the amount of islands that we have. And obviously this method is going to be returning this, so we can just hit enter a few times and type return num islands. So that method is set up. Now we have to just implement what's going to calculate the number of islands that we have. So the first step was we needed to transverse the entire 2D array. And to do that, you use a nested loop. So we'll create a loop for the outer, and we'll say int I equals 0 as long as I is less than grid dot. And we now need to get the length of, or basically the amount of rows that we have. So if you look here, just as an example, here we have 4 rows, 0, 1, 2, 3, and each row has 5 elements, or is an array of 5 elements. So we need the 4. And the way we do that is we need to get the first dimension of this array. So in C#, in other languages it's different, but in C# we can say get length 0 to get the amount of rows that we have. And then I++. Then when we're in a row, we want to transverse the amount of elements in that row basically, which is the amount of columns that we have. So we'll say for int j equals 0, as long as j is less than grid sub I dot length. So the amount of elements in a specific row, which this will always be 5 in our example, but I'll say j++. So now I have my basic loop set up. And remember, in the algorithm, the first thing that we did at every element, we said if it was a 1, then increase our number of islands by 1. So I can say if grid sub I, because it's row column, so we'll say the row and the column is j. So if grid sub ij is equal to a 1, then we know we have at least 1 island. So I'll say num islands ++. But now the challenge is, okay, we need to, from this island, so from the first position, we need to try to see how big is this island truly. And we'll do that, remember I said, by implementing a depth first search. So let's create another method. I'll call this private void DFS for depth first search, and it will take in the character array, this is the grid, and it will take in the row and column. So I'll explain why. The grid is there so that we know where to transverse to see how big this island is, and the row and column is our starting point. This is where the search is going to start, and it's going to dive as deep as it can to find the end of this island. So the first thing we need to do is we need to define the base case. This is what terminates this method basically. And remember, the base case is if we are surrounded by water. So if the left, top, right, or bottom, if they're all 0, or if any of those are 0, then we're going to skip this search because we're not going to go that direction. So if the left is 0, if the top is 0, the right is 0, or the bottom is 0, don't do anything in this. We're going to skip it. We only want to search. Remember, the purpose of depth first search is to find the end of the island. So we only want to continue to go if it is a 1. So if it's a 0, no, we back out. So our condition is going to be, remember, in the question, it said that if it's a 0, that's true, or if it's the edge of the board. So that means that if our current position is outside the bounds of this board, then we're in the water that surrounds the character array. So that's also not going to work. So I think this is more confusing by explaining. Let me just write the code and you'll see what I mean. So I'll say if our row position is less than 0, that means that if it's out to the left somewhere and this is less than 0, we're outside of our character array bounds, which means that is water, so we skip it. Or if row is greater than the amount of rows that we have. So if that's the case, then we'll say if row is greater than grid.getLength 0 minus 1. Remember, in our case, this is 4. So is 4 minus 1 is 3. So if rho is greater than 3, if you look, 0, 1, 2, 3. If it's down here, that means it's in the water. So return. So that's for rows. Then we'll say columns. If the column is less than 0, or if the column is greater than the amount of elements at that row. So we'll say grid.row.length minus 1. And I'll explain this all in a second with the diagram. So that's for these 4 conditions are to keep track of if we're outside the bounds of the grid. The last condition is if it actually is a 0, a part of our grid. So we'll say or grid.row column equals a 0. If it's equal to 0, if any of these conditions are true, we'll return. Meaning we're not going to try to dive any deeper. The search is over if any of these conditions are true. So let me just show you what this represents and what this means by using this chart. This means that the first 4 conditions, if row is less than 0, greater than get length 0 minus 1, less than 0, so basically all 4 of these conditions, what that means is this. If our row is either here, so the beginning, so if this is row 0, if we're here, return, or if the row is greater than the amount of rows we have, so that means if we're here, return. And then we say our columns, so we say if our column is over here somewhere, it's water, or if our column is over here somewhere, it's water. So those 4 conditions were for those clauses. The last one right here, if grid row sub column equals 0, that means if one of these are 0, we're inside the bounds, but it's a 0, then we return because we don't want to navigate that way. Okay, so if all of those conditions are met, we pass that, that means it must be a 1. So if it's a 1, we're going to set it to a 0. Remember, that's so that we can keep track of if we visited it or not. So I'll say grid sub row column equals a 0. So we set it to 0 so that we know we visited it. Then we need to do our depth first search. Remember, we go left, top, right, bottom. So we say depth first search, grid. Now, how do we go left? Well, to go left, we basically take our column and we subtract it by 1. So we stay in the same row and we take our column and we go to the left by 1. Then we do it for the top. So we say grid. To go up, we subtract our row by 1. Right? That goes up a row. And then we'll keep the column the same. Then to go to the right, we say grid. To go to the right, we keep the same row, but we increase our column by 1. And then to go down, we increase our row by 1. And we keep our column the same. So this will do a depth first search. It will go as far as it possibly can. And if this is a little bit confusing, go back to the part where I went through the algorithm at a high level using my diagram. This is exactly what we're doing. We go left, top, right, bottom until, and then at each position that we go, we check this condition. Is it a 0? If it is, skip it. We did exactly this in my diagram. So go back to that if it's a little bit confusing. This is a hard algorithm to understand. But after that, believe it or not, this will give us our result. All we have to do is call depth first search for the first time. Oops, I need to make this, you need to make this static since main is static. I call depth first search for the first time, passing in my grid, and then my row and my column. So it'll be I, J. So after it does the first element, it will see how big the island is. Once it found out how big it is by this returning on every single part of the island, this will finish. Then the loop will go to the next one until it finds its next one. So if I go ahead and run this, my answer is 3, which is the correct answer.